Reading through the question, you can see that it says in the second line that T is the time in years. But if you read the last sentence, it says which expression best approximates the amount of money in her account using a weekly growth rate. So we have a time difference here. So we know that weekly growth rate, we know that there are 52 weeks in a year. So then remember what we're going to do with that is 52 will go here because there are 52 weeks in a year. But if I put 52 there, I need to balance this out. And inside the 1.06 there, I'm going to raise that to the 1 over 52 power. Okay, then what I'm going to do is I'm going to take what's in parentheses here, this part right there, and I'm going to put that into my calculator and figure out that equivalent. So we're going to keep that 400. We're going to do 1.06 to the 1 over 52 power, and that gives me 1.00112, and to the 52t. And if you look at that, that's choice 4. Number 2 is very similar to number 1. So again, if you read the question, it says in the second line that time is measured in years. But if you read the last sentence, it talks about the expression that's equivalent to the d of t and could be used by students to identify an approximate daily interest rate. Well, in terms of a year, that would be 365 days, correct? Okay, now I can't fit it right here, so I'm going to put it at the end. So that means I need to put 365 days per year. And if I put 365 on the outside, then inside the parentheses, I'm going to take its reciprocal, which was 1 over 365. Then I'm going to take this value, put that into my calculator, and get the equivalent for that. And that will be, let's drop down the 29,400, and that will end up being 1.00018 to the 365t power. Now what I need to do is I need to go through and figure out which one is equivalent, or honestly, I really don't even need to go that far. If I look at choice 4, I see that matches what I had done right here. So once again, number 3 is very similar to 1 and 2. They give you this equation, and they, again, in the second line, tell you that time is measured in years. However, if you read the last sentence, it says using 52 weeks in a year, which of the choices will model the approximate weekly growth rate? So a weekly growth rate, remember, again, they said 52 weeks in a year, so 52 weeks in a year. Then remember, we multiply by the reciprocal exponent on the inside of the parentheses. And then we can just take this value, plug that into our calculator, and I get 1.010819. Bring down my b sub 0, my 52t. Oops, that should be a 0. And then we can see that that would be choice 3. Number 4 is a little bit different than numbers 1 through 3. So let's read this one through. So they're saying that last year the total revenue of a restaurant increased 4.9% over the previous year. So that means there's an increase, right? So plus of 4.9%. So there's 4.9% as a decimal. And it says over the previous year. So I'm going to use T for years. All right, so obviously I can just keep going and make that 1.049 to the T power. Okay. Now, if we read the question, it says, if this trend were to continue, which expression could the company's chief financial officer use to approximate their quarterly percent increase? Now, here's the trick, though. If you look at your 4 choices, we no longer have T's as our exponents. So there's a time conversion here. We're changing our t's to q's. So let's just kind of keep ourselves aware of that. All right, so then I'm going to say, well, I know quarterly means 4, right? 4 times a year. So let me put a 4 here, and let me put a 1/4 here, just like we always do. So that has not changed. Now I'm going to take this value, and I'm going to plug that into my calculator. And I get 1.01203. And remember, that's to the 4t power now. Okay, now normally we would look for our answer and see if it's there. However, because everything has changed to quarters, we're going to convert. So we have that 4, and then we know that t, which is years, is equivalent to quarters over 4. So then that means that we can take these 4's and cancel those out. So we have 1.01203 to the q power, and that's choice 1. Number 5 is very similar to number 4, because if you read the question, it does say that there's a decrease of 6.25% over the previous year. But what we need to understand and notice is if we look at our 4 choices here, we can notice that there are no exponents that are representing years. They're actually representing months. All right, so let's go back and read a little bit. So it says, suppose the company's revenue decreased by 6.25%. So a decrease would obviously be 1 minus 0.0625. Over the previous year, I'm going to use t for years. All right, so that is equivalent to 0.9375 to the t power. Okay, let's keep reading. So it says, assuming this trend continues, which expression could the company use to approximate the % decrease in revenue through a certain number of months? All right, well, months, we know that there are 12 of them in a year. Let's take the reciprocal of that, which is 1/12, and then we're going to put this into our calculator and see what value we get there. So then that's going to be, let's see, what do I have? 0.99463 to the 12t. Now again, normally I would just look for that answer as one of the 4 answer choices, but again, if you take note, I have 12t here, but everything here is in terms of months. So we have a time conversion. So what we're going to do is we're going to take this, and remember, I'm going to drop that 12 down, and t is equivalent to months over 12, and that will cancel out the 12s. So we end up with 0.99463 to the m power, which is choice 1. This one's a pretty easy question. Just go to your calculator, take each answer choice, plug it into your y1, and you're looking for an exponential decay. So decay means it would decrease as time goes on, which would be choice 4. Okay, again, just try each one separately, and if you look, 1, 2, and 3, working from left to right, they increase, where choice 4 is the only one that shows a decrease. All right, so with this one, I would start by just getting a graph. So I'm going to go to my y equals. I would plug that function in, and I would see that my picture looks like this. Okay. Now it asks which statement is true. So we want to know which one is true. The graph is not always increasing. The graph is actually decreasing as time goes on. So it's not that. But bing, bang, there we go, choice 2. All right, now let's just look at choice 3. It says that the graph passes through choice 10. Through 0.10. Now that's not the case. 0.10 is right around here somewhere, which doesn't happen. Okay, this graph has an asymptote, and its asymptote is the x-axis. In other words, if you were to go to your table and look at your table of values, you will see that this will never ever approach a y value of 0. It'll get closer and closer to it, but it's never going to hit it. So it would never pass through the point 1 comma 0. All right, next, let's look. It says the graph has an asymptote at x equals 0. Well, x equals 0 is the y-axis. That's not the case. It has an asymptote at y equals 0, which is the x-axis. Okay. If you look, they gave you the equation x equals 3 to the y. Now, you can't put this in your calculator because we don't have an x equals. But what I can do is if I take this and flip my y's with my x's, now do you see that I actually can take this equation here and put it into my y equals? Okay, now, do you remember what happens when you switch your x and your y? What is that called? What I did was I took the inverse. So what I would do is I would go to my table of values and I would look at the values. And let's just say I have -2, -1, 0, 1, 2. You could just to give you an idea, not that you really need to write all this down because it is multiple choice, but that would give you 1/9. Now on the calculator it's going to give you the decimal equivalent. 1/3 here, 1, that'll be 3, and this will be 9. Now, it would be a little bit easier if you just looked at the graph. And if you look at the graph, it's going to look like that. So an inverse, remember, is a reflection in the line y equals x, right? So let me just draw that. So here's the line y equals x. So if I reflect that blue graph over my red line there, it should look something like that. Okay, and you can see that that's choice 3. Now the other option is I could take all of these points if I wanted to, and I could flip them around because an inverse is to switch the x and the y around, right? So, in other words, instead of writing -2, 1/9, I can flip that around and I can make that 1/9, -2. And if I plot that point, I'll get something like down here, okay? And then I can do 1/3, -1. And I would probably get something right around here. Then I could do 1, 0, and I would get that point right here. Then I could do 3, 1, which would give me roughly this point right here. And then lastly, I could do 9, 2, which would probably be something all the way out here. And again, then you can see that it's answer choice 3. But I think the easiest thing to do for you would be to take this equation, put it in your y1, get this picture right here, and then remember, an inverse is a reflection in the line y equals x, so it should look like this. You're asked to solve for t. So in that case, we're trying to get the t by itself. So the first thing I would do is I would notice that I could divide out the x, and then that would leave me with e to the yt power equals z over x. Now, I have an exponential equation, but we have to be careful because that exponential equation has an e in it. So remember, if we want to get rid of an e or bring our exponent down, we would ln. So we're going to take that yt, and we're going to multiply it. Let me just backtrack just 1 second. I am going to multiply it, but so I'm going to ln this base, and I'm going to ln that base. Okay. So now, going back to what I was saying, sorry about that, I would have yt times the ln of e equals the ln of z over x. Now remember, the ln of e is just 1. So then that leaves us with yt equals the ln of z over x. All right, now again, just remember that we're trying to solve for t, so I want to get rid of what's attached to that t, which is the y, and since they're being multiplied, I'm going to divide. So then I have t equals the ln of z over x, all of that over y. And there is my answer. And then let's go up and let's look at the answer choices, and that is choice 4. So the question is asking essentially to find your average rate of decay, which would be your average rate of change, and we want to see which one is decaying the fastest. So in choice 1, you're just going to do actually, hold on a second. You're not going to do f of 10, you're going to do n of 10 minus n of 1 over 10 minus 1. Okay, so my suggestion to you would be to take this equation here that I'm boxing off, put that in your y1, go to the table of values, and then go down to where x equals 10, and you'll see that it's 158.91. Minus, now again, go to the table of values, find out where x equals 1, and look at the y value, and that's going to be 195.45. Then we're going to subtract those two numbers, and essentially we're going to divide by 9. So when I do that, I get negative 4.06. Okay, so we're going to do the same thing for choice 2. Obviously, though, we're going to do n of 20 minus n of 10 over 20 minus 10. So the same thing. You already have the n of t equation in your y1. Go to the table of values, go down to where x is 20, and you'll see that that's 126.26 minus n of 10, which is 100, ooh, that's a minus sign, 158.91 over 20 minus 10, which is 10. And that's negative 3.265. Okay, choice 3, we're going to do n of 25 minus n of 15 over 25 minus 15. Go to the table of values, and n of 25 is 112.54 minus n of 15, which is 141.64 over 10, and then work that out, and we get negative 2.91. All right, choice 4, same thing again. So we're going to do n of 30 minus n of 1 over 30 minus 1, and we go to our table of values where x is 30, and you'll get 100.32 minus, and this is 195.45, and we divide that by 29. And we get negative 3.28, and then I believe it's 03, so on and so on. Okay, now, if you read the question, it wants to know which one has the fastest average rate of decay. So these are all decaying. We see by the negatives that all of them are decaying. But which one is the fastest? Well, fastest means steepest. And 4.06 has the steepest slope. Okay, look at it as absolute value. This would have the largest value if it was in absolute value, because that would get rid of your negative. Okay, where these numbers here aren't as steep as 4.06 is. All right, so your answer is choice 1 then. So my first thought after reading this question and looking to see that they want me to find the average rate of change, which I see right here, average rate of changes, and they want me to compare the average rate of change between 6,000 to 8,000, and then compare that to from 9,000 to 12,000. So my first thought was, well, let me put this in my Y1 and go to my table of values like I did on number 11. But I would have to go to my table of values and find 6,000 as an X value. So that seems a little bit ridiculous. I'm going to be scrolling for quite some time. So then I figured probably the best thing to do then at this point is to plug numbers in. So for example, the equation is T equals 1 over 0.0105. Then it's the ln of, now A. Well, A is technically, really, it's your X value. And our first X value, if we look at the first interval that they gave us, would be between 6,000 to 8,000. So I'm going to have to plug both of those in, obviously one at a time. Doesn't really matter which one you do first. So let's just say I put in 6,000. So then 6,000 over 5,000, I'm going according to the formula. And I would just plug this into my calculator. And I end up getting 17.3639. It keeps going. Okay, so then I would do the same thing again, 1 over 0.0105 ln, and this time put in 8,000 over 5,000. Okay, and when I do that, I get 44.7622. All right, so again, this is when the X value is 6,000. This is when the X value is 8,000. So now I can do average rate of change for the interval 6,000 to 8,000. So I'm going to do 44.7622 minus 17.3639, and then I'm going to divide that by 8,000 minus 6,000. Okay, and then that's going to give me 0.0136. All right, now I'm going to repeat the same idea, but using 9,000 and 12,000. So T equals 1 over 0.0105 ln, and then let's put in 9,000 over 5,000, and that is going to give me 55.9796. And again, that's when I put in 9,000 for X. All right, now we do it again. So 1 over 0.0105 times the ln of 12,000 over 5,000. Plug that in my calculator, and I get 83.3779. And that's for the X value of 12,000. Okay, now we're going to do average rate of change. So that's 83.3779 minus 55.9796, and we're going to be dividing that by 12,000 minus 9,000, and that ends up being 0.00913. So let's look at this value and compare it to that value. All right, so we can see that the average rate of change at the interval from 6,000 to 8,000 is larger than the average rate of change for the interval from 9,000 to 12,000. Okay, so then we can see that that's choice 3. So we've got average rate of change again, and they want from June 2012 to June 2014, but Greg purchases his car in 2011. So that means June 2012 is really T equals 1, and June 2014 is t equals 3. Okay? And they want the average decreasing rate of change per year of the value of the car. That's V. So I want to try, if I can, to get this equation to say V equals, since this is saying to find the average decreasing rate of change of the value of the car. So I'm looking at this and I'm saying, well, that's a log equation. I can circle the base and run the race, and that might help me start to get the V by itself. So when I circle the base, run the race, that gives me 0.8 to the t power equals V over 17,000. All right, well, can I just put this over 1 and cross multiply? So V will equal 17,000 times 0.8 to the t power. Okay. Now, from here, I want to know at time 1 and at time 3. I want to know what their y values are, or what V of 1 is and V of 3 is. So you can go about this a bunch of different ways. We could just simply take the V and do 17,000 times 0.8 to the first power. That would be at time 1. Figure that out. And then let's do V, 17,000 times 0.8 to the third power, because that would be at time 3, and figure that out. Okay, so at time 1, I get 13,600, and at time 3, I get 8704. So if I am doing the average rate of change, I'm going to do 13,600 minus 8704 over 1 minus 3. Now I could have done it the other way around too, it doesn't matter. So when I work all this out, I get negative 2,448. Now read the question, because it says to the nearest $10. Well, here's my $10 spot right there. So there's an 8 after that, so that's going to round that guy up. So then my answer is going to round to negative 2450. Now, we are decreasing since the value of the car is depreciating, that's why we have the negative, but they want to know what the decreasing rate of change would be. It would still be 2,450. Choice 3. I split my paper up here so that you can see what Jonesville's equation will be, growth equation, as well as Williamstown. So now if you look at Jonesville, let me see. So they start with an initial population of 1,240, and it is an increase of 6%, so that would be 1 plus 0.06 to the t. Okay, now let's look at Williamstown. So their initial population is 890, small town, 1 plus, but they have a larger growth rate, so that would be 0.11 to the t. Now my suggestion would be to throw this into your y1, throw this into your y2, and get yourself a picture. You are going to, though, if you notice, though, you have larger numbers here. You've got 1240 and you've got 890. So you're going to have to make your Y max is going to have to be pretty high. Somewhere, I don't know, I would say probably somewhere around 2,000 or so is what I'm guessing. So when I do that, just to show you, my Jonestown is going to look like this, and I will call that J of T for Jonestown, J. And then my Jonesville, sorry, then my Williamstown will come across like that. Okay, I'm going to put that over here. So here's my Williamstown. This is the y-axis, this is the x-axis. Okay, so if you look at that, you'll see that my point of intersection is right here. So you're going to do second calc, intersect, and you will get 7.1954, comma, 1885.8545. Okay. All right, now let's just read it. It says, assuming the trend continues approximately how many years after the beginning of 2018? So after the beginning of 2018, that would be at time 0. So we can see that their t would be our time, which would be our x value. So they just want how many years that would be. That would be our x value of 7. So that would be 7 years. Okay, and again, just to reiterate that when you're trying to graph this, look at my y value here. It's 1,885. So when you're graphing this, if you go to table, or your window button rather, in your calculator, make sure that your y max is probably up higher than this. So I would say 2,000 to maybe 2,500, and then you'll see the picture, I think, pretty easily. And then we do second calc max. I'm sorry. Oh my gosh, I'm making all kinds of mistakes. Second calc intersect. Okay, left bound hit enter, right bound hit enter twice, and you'll get that. Just make sure that you read this question carefully because it does say which value to the nearest tenth is not a solution. And then also remember that when we see two functions set equal to each other, that means that the answer that they're looking for will contain x values only. Okay, so I would probably just start by plugging, let's say, p of x into your y1, q of x into your y2, and here's the graph that you're going to get. So p of x is your cubic right here, q of x is your line right here, and I just drew a rough sketch so you can see it that I have 1, 2, 3 intersection points. So second calc intersect and find those 3 values. So what I did was when I found those 3 values, I got x equals negative 3.9. That's the one on the far left. Then I found the one in the middle, which was x equals negative 1.1. And then the one on the far right, I have x equals 2.054. So those are solutions. They want to know which one is not a solution. So that would be choice D, 4.7. So remember, whenever they want you to write an equation of a parabola, I would always draw a picture. So we have a focus of negative 4, 4. So 1, 2, 3, 4. 1, 2, 3, 4. There's my focus. And the directrix is x equals 2. You know, let me put that in a different color just so that it doesn't get mixed up with the y-axis. So there is my x equals 2. All right, so now if you remember, the vertex of your parabola has to be halfway between the focus and the directrix. So right smack dab in the middle here. Now, the focus here is 4 units away from the y-axis, and the directrix is 2 units away from the y-axis. So that's a total of 1, 2, 3, 4, 5, 6. So I want to cut that in half, and I will get 3. So then I know that my vertex is going to be right there because I am 3 units away from the focus. Let's count that. 1, 2, 3. Here we go. And I'm also 3 units away from the directrix. 1, 2, 3. Now remember, the parabola can never touch the directrix. So in this case, my parabola is going to be opening to the left like that. All right, now that I know that my parabola is opening to the left. Let me write down a couple of other things I know. So I know the coordinates of the vertex are -1, 4. And since the directrix is let me say that again. Since the vertex is 3 units away from the focus and 3 units away from the directrix, then I also know that P is 3. Okay, so because I open to the left, the other thing I also know is my equation is going to be x equals, and it opening to the left means that my 1 over 4p will also be negative. So that will be -1 over 4 times p, which is 3. Then I'm going to put, since I have an x equals, that means I'll have a y in the parentheses that's squared. And just remember, if I have a y in here, then the number that goes along with that y is the y coordinate of my vertex, which would be the 4. But don't forget, we have to change the sign of any number that goes in parentheses here. So since this 4 is a positive 4, in here I'm going to put a -4. So minus 4. And then lastly, since y is in here, and this is the y value associated with the vertex, then the x value associated with the vertex goes out here without the sign changed. So since the x value is a -1, then I'm just going to put a -1 right there. So that will be -1. Okay, now let's just pretty that up a little bit. So x equals -1 over 12 times y minus 4, that quantity squared, -1, and there's your equation. Now 16 is kind of the reverse order of number 15. So this one gives you the equation, and we need to find the focus and the directrix. So remember, what we start by doing is we actually look at the equation that's given, and we want to get the variable that does not have the square term, in this case the y. We want to get that variable by itself. So I'm going to start by dividing both sides of the equation by -10, which will cancel out the -10 on the left side, and I'll be left with y plus 2. And then on the right side, I'm going to make that -10 that's in the denominator, and I want to make it look like that 1 over 4p. So I'm going to write it like that, with the x plus 5 quantity squared next to it. All right, then next, remember, I'm going to subtract 2. Subtract 2 because we're trying to get that y by itself. And I have y equals -1 over 10 times x plus 5, that quantity squared, minus 2. Okay, so what does that tell me? Well, that tells me because I have a y equals, I know that I'm opening up or down. And since my 1 over 4b here is negative, I know that I'm going to be opening down. So, first thing that I know is that we are opening down. Okay, the next thing that I know is, let's look for the vertex. Well, my vertex here, this represents an x value because I have an x in the parentheses. But remember, I need to negate whatever number's in the parentheses. So the x value of the vertex is -5. This represents the y value. Remember, that value, its sign does not change. So the other thing then that I know is that the vertex will be -5, -2. Okay, the last thing I know is the value of p. Now remember that this fraction here, -1 over 10, is 1 over 4p. So this is saying 4 times some number p gives me 10. So let me write that over on the side here. So 4 times some number p gives me 10. So if I just divide by 4, I will get what the p is, and that would be 2.5. Okay. All right, so I'm going to draw a sketch. So if I go over here, I'm at -5. 1, 2, 3, 4, 5. -2. 1, 2. Okay, there's my vertex. And I know that it opens down. So I'm going to go like this. And then I know that my P is 2.5. So let's think about a couple of things about that. So 2.5, if I go from my vertex and I count up 2.5, I'll get the focus. Okay, so let me just do this real quick. Add a couple of these, add a couple of these, and I think we should be good to go. And I think I just said the wrong thing, didn't I? Anybody catch me on that? I said if we go up 2.5 from here, I will get the focus. I meant the directrix, I'm sorry. So I'm down here at -2, and I need to go up 2.5. So that would be 1, 2, and then 0.5 would be right here in between 0 and 1. So let me just draw that real quick. So then that means my directrix will be right there at y equals 0.5. Now let me show that again just in case. So I'm down here at -2, and I counted up 1, 2, and a half. And there's my directrix. Now if I want my focus, I'm going to go from the vertex, and I'm going to count down 2.5. So here I'm at -2, 1, 2, and a half. Right in there. Okay, so that will put me right about there, right? All right, so that would be right there. Now let's count the spaces I have here. So if I'm right here from the origin, I'm 1, 2, 3, 4, and a half. So 4.5 down. All right, so then that means that the coordinates of my focus will be -5 to the left, and then down 4.5 or 4.5. And then my directrix is the line y equals 0.5. I always like to simplify what's inside the parentheses first. So if I look at this, I see that I have division, and both of these bases are both x's. So I know with division, I can just subtract my exponents. So you can take your calculator, and we keep the base, and then we're going to subtract the exponents. So 2 minus 1/3. Okay, so 2 minus 1/3 is 5/3. Then keep that -1/2 power. All right, the next thing that I would probably do, and you can do this in different orders, but I have power to a power here. So that rule is when you have a power to a power, you multiply those two exponents together. So that's going to give me x to the -5/6 power. All right, now that's not one of the choices. So what I would probably start by doing is let's get rid of that negative exponent. And we know we can do that by dropping down that x to the -5/6 to the denominator, which would make that x to the +5/6. And then lastly, don't forget that we have power over root. So my power would be 5, and my root would be 6. So in other words, if I wanted to write that, I would write 1 over root of 6, right? And to the power of 5. So we've got power over root. And then if we look at the answer choices, that would be choice 2. So with 18, I'm going to do power over root rule, and I am going to take everything out of that radical form. So that would give me x to the, now we want power, which would be 8, over root, which would be 3, times. And then I have x to the power of 3, and that's a square root. Remember that even though there's no index number right here, if there's nothing written, we assume that that's a 2 for a square root. So this would be to the second power. I'm sorry, over 2 rather. All right, now in the denominator, I have a power to a power, so I'm going to, just like in number 17, I'm going to multiply those two. So we keep the base, we multiply those exponents, and we will get 4/3. And then if you look at the right side of the equal sign, that says x to the y power. All right, so let's go back to the left-hand side. So we want to now, we have 2 of the same bases. We're multiplying here, so that means we add these exponents. So in your calculator, you can just do 8/3 plus 3/2. And that is going to give us x to the 25/6. And then that is going to be over x to the 4/3. Then because I have division, same base, subtract those exponents. So you're in your calculator going to do 25/6 minus 4/3. And that, oops, let me also just put here that this is x to the y power, sorry. Okay, so then when I subtract those, I end up getting x to the 17/6. And this equals x to the y. Now read the question. It says determine the value of y. So it wants to know what y is equal to. Well, listen, guys. If these two have to be equivalent to each other and they have the same base, then the only way they're going to be equivalent is if y was 17/6. Pretty easy, right? So y is equal to 17/6. So with this question, they gave you the equation of f of x equals log base 3 of x. And then what they want you to do is take that and translate it. In other words, move it 5 units to the left. Now remember when things go horizontally, we use the opposite sign of the direction that we're going. So since this says translate 5 units to the left, we're actually going to have a +5. And then also remember that any horizontal translation, in other words, to the left or to the right, we put that in parentheses to signify a horizontal translation. So the answer is choice 1. Now, just be careful because choice 2 is a horizontal translation, but that -5 means actually go to the right 5 units. Okay? So now, technically, this is no longer f of x, it is now g of x, because they said g of x was the image of f of x after we translate it 5 units. So, there you go. So they're asking what 80 represents in the given equation, and that would represent the initial population of wolves in 1998. The starting population, you know, they're talking about since 1998. Also, please remember that we told you in class, and let me just stick this in if I can, that right there we wanted you to write the word January. So let me kind of reiterate what I just said in part A. So that 80 would represent the initial population of wolves in January. Oh my gosh. Sorry about that. I know that doesn't look like a J. In January of 1998. All right, now the 0.98, remember we discussed that if that number is less than 1, it's actually a decrease. And since we're talking about the population of wolves, that would be a decrease in the population of wolves. So the number of wolves decrease by, and this is 1 minus 0.98. So if I do 1 minus 0.98, I get 0.02. And if I want to write that as a percent, remember we move the decimal place twice to the right. And so that would be a decrease of 2%, that says a percent, that's a percent symbol, 2% per year. Okay, so the 0.98 represents a decrease in the wolf population of 2% per year. Now, it says, during what year will the population of wolves be 50 or less? So what I'm going to do is I'm going to start with that P of T equation that they gave me, and I'm going to set it equal to 50, because I know it can be 50. It can also be less, which we'll deal with that in a minute. So 50 equals 80 times 0.98 to the T power. Okay, so we have an exponential equation. So let's start by trying to get that T by itself. So this is going to give me 5 over 8 equals 0.98 to the T power. So remember, if we want to get an exponent down, we would log both of our bases. I'm just going to squeeze this in here. I'll rewrite it. And then we can take that exponent and we can stick that in front, right? All right, so that's going to give me the log of 5/8 equals T times the log of 0.98. Let's divide out the log of 0.98. Throw that into my calculator. Log of 5/8 over the log of 0.98. And you should get 23.2643. Now, let's read the question carefully, because the question says, during what year? It doesn't say how many years. So what we have down here, that 23 point blah, 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 tells us how many years it took for the population to get to be 50 wolves. But the question wants to know, what year is that? So then from there, we want to look at the fact that this whole scenario began in January of 1998. So if I add those 23 point blah, blah, blah years to the 23 point blah, 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 we will figure out what year that was. So if I add that, that's 2021.2643. Okay, now, we did this question, or something very similar to it, back in December. And if you recall, what this is saying is, because the whole scenario began in January of 1998, right here, this is also January of 2021, plus 0.2643 more. So a little bit more than 2/10 of a year more. Now, will a little bit more than 2/10 of a year bring us to 2022? No, it won't. So then our final answer would be 2021. Let's also address the fact that not only does the question say, during what year will the population of wolves be 50? This is the time or the year where the population will be 50. If time ticks away further and further and further, then the population will become less than 50 as well. Okay, but since the question says, during what year will the population of wolves be 50 or less, that first time that happens is 2021. So Nick has 3 investment options, and option A will pay him 2.4% compounded annually. So that would be, let's try that again. That would be A of T equals his initial investment, which is going to be $8,000, 1 plus 0.024 to the T power. All right, now option B says that it will pay him 2.375%, but compounded quarterly. So that would be B of t equals, again, the same initial investment of $8,000. Okay, 1 plus, now the rate is 0.02375, but it's quarterly, so that's 4 times a year to the 4t power. Option C says that it will pay him 2.35%, but compounded continuously. So that's a per. So let's use C of t equals the initial investment times e to the rate, which would be 0.0235 t. And those are your three equations. Okay, so Part B wants to know which account is going to earn him the most money over a 10-year period of time. So what I did was I took the A equation and I plugged in 10. So this was the setup, and then I just raised it to the 10 power for 10 years. B of 10, same thing. Here's my setup, and then my T is 10. C, here's my setup, and then again, T is 10. All right, so then you can just plug those into your calculator. This one is going to give you 10,141.205. This B of t, or B of 10, I should say, is $10,137.478. And lastly, C of 10 gives me $10,119 and 0.2702. Now, obviously, I would round these money-wise, but we can look, it just says which account will earn the most money. So account A is the one that has the largest amount of money. Not that it asks it, but if it did, it would be $10,141.21. I would round that. I would round this 0 right here to a 1 because the 5 would bring that up. Okay, but if you just look on to the left of the decimal, you can see 141 is bigger than 137 and is bigger than 119. So it will be account A. And let me just write that just so nobody has any questions. Here we go. So they want us using option B, and they want the investment to double. So if he starts with 8,000, that means when things double, he'll end up with 16,000 equals 8,000 times 1 plus 0.02375. That whole thing over 4 raised to the 4t power. All right, so I am going to try to get that t exponent to be more by itself, so I'm going to start by dividing out the 8,000. And that's going to give me 2. So 2 equals 1 plus 0.02375 over 4, that quantity to the 4t power. Okay, so then here, I want to try to get that exponent down in front. So remember, we can bring that exponent down in front as long as we log both the bases. So let's rewrite that and make that a little prettier looking. So that would be log 2 equals 4t times the log of, and then that whole mess. So 0.02375. That whole thing divided by 4, there we go. All right, so now I'm actually going to divide by that whole mess. So the log of 1 plus 0.02375 over 4. And I would do the same thing over here, obviously, because that's going to cancel that mess out on the right side. Bing. All right, so then I'm going to get an answer. Now, when I throw that all into my calculator very carefully, I get about 117.086809, and it keeps going, but just to give you a general idea. And then that equals 4t. We divide out that 4, and we have t equals 29.2717, and it says to the nearest year. Okay, how long it's going to take to the nearest year. So that would be 29 years. Okay, so algebraically determine to the nearest tenth of a year how long it would take for option C to increase his initial investment by 4,000. Well, if he had 8,000 to begin with and he increases it by 4,000, that would make that investment over a certain span of time, which we're going to find out, equivalent to $12,000. Initial investment of 8,000, e to the 0.0235 t. Okay, so just like in part C, let's try to isolate that t a little bit more by dividing out that 8,000. Okay, so that gives me 1.5 equals e to the 0.0235 t power. Now, similarly, but yet a little bit different, remember that when you're trying to bring a power down in front and the equation has an e in it, we ln. Okay, so we're going to ln both bases. So we get the ln of 1.5 equals 0.0235t, and then that quantity is going to be multiplied by the ln of e. Now remember what the ln of e is, though. That's really just 1, so we can get rid of that. Now, lastly, I would just divide by the 0.0235 to isolate, oops, stick a 3 in there, to isolate that t, and then plug in this right here into our calculator. Okay? All right, and then I end up getting t equals 17.2538, and it says to the nearest tenth of a year, so that would be 17.3 years.